Hello everyone, welcome back to my channel. In this video, we will see regression and logistic modeling. So let's get started. In this video, we will explore the regression and logistic modeling. Today, we will dive into the world of statistical modeling, uncovering its power and application in data analysis. We will explore how regression models estimate relationship between variables and how logistic models predict categorical outcomes. Simple linear regressions. Let's understand the basic. Simple linear regression analyze the relationship between two variables, one dependent and other independent, seeking to establish a linear equation that best fit the data. This model helps us to understand how changes in the independent variable affect the dependent variable. Let's take an illustrative example. Imagine if you want to predict house price based on their size. Simple linear regressions could help us to find the relationship between square footages and price, providing a prediction equation for estimating house values. Multiple linear regressions. Multiple predictor. Multiple linear regressions allow us to model the relationship between dependent variable and multiple independent variables. This enables us to capture more complex relationships, accounting for a wider range of factors that influence the outcomes. Predictive power. Imagine predicting customer satisfaction based on factors like product quality, price, and customer services. Multiple linear regression can incorporate this factor to provide a more comprehensive model for predicting satisfaction. Data insights. Beyond prediction, multiple regressions are used in individual contribution for each prediction. Regression diagnosis. Accessing model assumptions. Linearity. Verifying the linearity assumption ensure a linear relationship between dependent variable and the independent variable. Residual plot help us to identify derivation from the linearity, suggesting potential adjustment to the model. Independence. The independence assumption ensure that the efforts are not correlated with each other. Time series data may exhibit autocorrection requiring adjustment to the model. Normality. The normality assumption suggests that the efforts follow a normal distribution. QQ plots help visualize, assess normality, and guide decision on the model adjustment or alternative approaches. The next one implies the constant variance in the error across the range of predicted value. Examining the residual plot for the pattern or uneven spread indicate potential issues with these assumptions. Regression model evaluation. First, R square. It measures the proportion of variance in different dependent variables explained by the model. A higher R square indicates a better fit, but does not guarantee a good model. RMSE, root mean square error. It is a measure of average difference between the predictable and the actual values. Low RMSE indicates better prediction accuracy. MAE, mean absolute error. It is a measure of the average absolute difference between the predicted and the actual value. Lower MAE indicates better prediction accuracy, more robust to the outliers. Let's see stepwise regression. Forward selection. Starting with no variable, the algorithm adds variable one by one, selecting one that improves the model fit the most at each step. This continue adding until further variable does not significantly improve the model. Backward elimination. Starting with all the variables, the algorithm removes variable one by one, removing one that contribute least to the model fit each step. This continue until removing further variables significantly worsen the model. Third, stepwise selection. A combination of forward and backward selection. Alternatively, adding and removing variables based on statistical significance. This approach aims to identify the optimal set of predictors for the model. Let's see logistical regression modeling. Prediction, categorical, and outcomes. Prediction categories. Unlike linear regression that predict continuous outcome, logistic regression predicts categorical outcomes such as whether a customer will click on an ad, yes or no, or whether a loan will default, yes or no. Sigmoidal function. The sigmoidal function transforms a linear combination of predicted variable into a probability range from 0 to 1, providing a continuous probability estimated for the categorical outcome. Application. Logistic regression is widely used in areas such as marketing, finance, healthcare, and social sciences for making prediction about the categorical outcome based on relevant factor. Logistic regression for binary outcome. Let's take a practical example. Imagine we have a dataset with information about borrowers, including age, name, credit score, and whether they will default a loan or not. Logistic regression can help us to predict the probability of borrower defaulting based on their characteristics. Model interpretation. The model's coefficient reveals the relationship between each predictor value and the probability of default. A positive coefficient means a higher value or the predictive increase the probability of the default, while a negative coefficient indicates the opposite. Interpreting logistic regression coefficients. First, odd ratios. Logistic regression coefficients are expressed in terms of odd ratios, which represent the change in odd of the outcome for one unit increase in predictable value. For example, an odd ratio of 2 means the odd of the outcome double for every 1 unit increase in predictor. Second, sign of the coefficient. The sign of the coefficient tells us the direction of the relationship. A positive coefficient indicates a positive relationship where an increase in predictor increase the probability of the outcome and vice versa for the negative coefficient. Third, magnitude of the coefficient. The magnitude of the coefficient indicates the strength of the relationship. Larger magnitude implies a stronger relationship between the predictable variable and the outcome. Voice regression for count data analysis event. Voice regression is designed to analyze count data, represent the number of events that occur within a specific time interval or space. This model is particularly useful when the dependent variable is count, such as the number of website visit, customer complaint, or accident. So here we come to the end of this video. Thank you for watching the video. Please do like, comment, and subscribe my channel for further updates. Thank you.